In this video, we're going to talk about the properties of rational exponents, and the properties are identical to the properties of normal exponents. Let's look at the properties. Product of powers. That means that when I'm multiplying numbers that have the same base, and I'm multiplying, then I can add the exponents. I would add the exponents, addition, okay? So this becomes, I keep the base, and I take the exponents and I add them together. 1/2 plus 3/2, that gives you 12 to the 4/2 power, and that gives you 12 to the second power because 4 over 2 is 2, and then you get 144. And there you have it. For the second example, the quotient of powers. The quotient means we have a division instead of multiplication. So when we multiply, we add. When we divide, we subtract exponents. So what we do is we keep the base and we subtract the exponent. So I would have 2/3 minus 1/3, and that equals 125 to the 1/3 power, because 2/3 minus 1/3 is 1/3. And this number here, I know I can change this into the cube root of 125, and that will equal 5. Okay? Power of a power. The power of a power says that I can, if I have this power raised to another power, 2/3 raised to the 3rd power, then I can multiply the exponents. So far we have addition when we multiply, subtraction when we divide, and when we're raising a power to a power, we multiply exponents. So this equals 8 to the 2/3 power times 3. We can go off to the side here. What's 2/3 times 3? Okay, remember 3 is over 1. So I can cross cancel 3 and 3, and that gives you 2. So I know that 8 to the 2/3 power times 3 is equal to 8 to the 2nd power, which is 64. Let's look at the other property. Power of a product. That means if I have inside the parentheses, I have a number times another number, and those two numbers that are being multiplied are raised to a power, then I can distribute this power to each one of the numbers. Okay? So this becomes 16 to the 1/2 power times 125 to the 1/2 power. And we can simplify that. 16 to the 1/2 power is the same thing as the square root of 16 times the square root of 125. The square root of 16 is equal to 4. The square root of 125 I can rewrite as 25 times 5. That means I would be able to separate this into the square root of 25 times the square root of 5. Square root of 25 is 5, square root of 5. So 125 simplifies to 5, square root of 5. So I have 4 times 5, square root of 5. And 4 times 5 is 20, square root of 5. And this would be your final answer for that one. And the power of a quotient is just like the power of a product. If you have a quotient or a fraction inside the parentheses and it's raised to a power, you can simply distribute this exponent to each one of the numbers. So this becomes 16 to the 1/4 power divided by 81 to the 1/4 power. Now I can change this into a radical, and this becomes the 4th root of 16 over the 4th root of 81. And the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. And the 4th root of 81 is 3, because 3 times 3 times 3 times 3 is 81. So this will be your final answer. So here you have all the examples of all the properties for rational exponents, and I will give you some practice problems. So hit pause so you can do the practice problems. when you see them and then come back for the answer. Here are your practice problems. Hit pause so you can work on them and come back to see the answers. Here are the answers. For the first problem, we have that we're multiplying the same base. That means we can add the exponent. So when I add 3/5 plus 2/5, I get 5/5. That makes 1. So the answer is 25. Our second example, I have a quotient. So we have to subtract. We have the same base. We subtract the exponents. 1/3 minus 2/3, that gives you negative 1/3. Remember, we never want negative exponents. And one way to fix that is to write the number downstairs. And then the exponent will be positive. So that's what I did. I wrote 1 over this whole thing in the denominator, but with a positive exponent. And then in the denominator, 8 to the 1/3 power, I can rewrite as a radical. That's the cube root of 8. So it's 1 over the cube root of 8, which is 1 over 2, because the cube root of 8 is 2. For example 3, I have a power raised to a power. So we said that whenever you have that, we multiply the exponents. So 64 raised to the 1/2 power times 1/3, that gives you 1/2 times 1/3, that's 1/6. And if we change it to a radical, we have the 6th root of 64. And that is 2, because 2 times 2 times 2 times 2 times 2 times 2 is 64. For the fourth example, I have a quotient raised to a power. So remember, that's like distributing this exponent to each one of the numbers. So 8 to the 1/3 power and 27 to the 1/3 power. This I can change into a radical. This is the cube root of 8, cube root of 27. And then the cube root of 8 is 2. The cube root of 27 is 3. 2/3 is your answer. This one here, we have a power here. We have a product, and we have it raised to a power. Again, we can distribute this exponent to each one of these factors. So I have 8 to the 2/3 power times 64 to the 2/3 power. 8 to the 2/3 power I can write as a radical. Remember that the exponent, the numerator, I can raise the whole radical to that numerator, and the denominator is your root. And the same thing for 64. We change it to radical. I do parentheses first, so the cube root of 8 is 2, and I raise it to the 2nd power, which is what I have to do. And for this one, the cube root of 64 is 4, and I raise it to the 2nd power, which is 2. 2 squared is 4. 4 squared is 16. 4 times 16, 64. That's the answer. I hope you got these right. If you didn't, go back, try them again, and check your answers. Again, I'll see you in the next video.